So the question is here, all I need to do is to draw the circle, the earth, a replica of the earth. Okay. Replica of the earth. Okay. So I have this. That's the earth for me. So let's represent. An airplane flies due west. All right. For 3 hours. For 3 hours from P to a point Q. So let's get the P. P is 50 degrees north. 50 degrees north. 50 degrees north. And 60 to the west. Okay. So 60 to the west is going to be here. The west. So this is my 60 to the west. Alright, so where the points met, the 2 points met is P. Now the aeroplane flew from this P down towards the west side. That's what the question says. It moved due west for 3 hours. So it moved towards this side, towards the western part, to a new point Q. We don't know the longitude of that Q, so we just draw the line, and we could call it X. So this is the longitude of that one. So I can call it X degrees west. Okay, so where the two of them met, that point there is called the Q. Okay. Now if you look further, you see to a point Q at an average speed of 60 kilometers per hour. Okay, 60 kilometers per hour. Now we went further to say that the aeroplane then flies due south from Q. So that means it's along this longitude X. Okay, from Q to a new point Y, 50 kilometers away, 500 kilometers away. So it is not a big kilometer, so it's still in the northern part of the earth. So this will move down to a point here, so I can call this particular place Y. So here is our Y. This is our Y here. Okay, call here Y. So this particular latitude, I don't know the value, so I can call it Z degrees north. Alright, so let us calculate the distance from P to Q. Already they gave us the hour it took to travel from P to Q and the average speed. So generally we know that speed is equal to distance over time. Okay, so distance will be equal to speed times the time. Alright, so the speed given there is 600 kilometers times the time taken is 3 hours. So if you multiply, we'll be definitely having 1,800 kilometers. 1,800 kilometers. So that's the distance from Q to P, right? But we are not looking for distance, but we needed to calculate the angular difference between point Q and point P. We need it. So what do we need to do? We say that PQ distance is equal to theta over 360 times 2 pi capital R cos alpha, because the distance is along the latitude. So theta is what we are looking for. We don't know it. Okay, so but we know the value of PQ, which is the one we have calculated at this distance here. So it becomes 1,800 is equal to theta over 360 times 2 times the pi given here is 22 over 7 times 6,400 times cos 50. Okay, so cross multiplying, theta will be equal to 1,800 times 360 times 7 divided by 2 times 22 times 6,400 cos 50. So the theta after calculating this gave us 25 degrees. Okay, but not on the dot, it's 25 point something. All right, let me 25.06 degrees. Okay, so that is the angular difference. So let us calculate. The first question says we should find the longitude Q, the longitude of Q. All right, the longitude of Q. So we'll use the angular difference there. Okay, so we know this implies that theta is equal to since it is along the same latitude, we make use of this particular longitude and the second longitude. So the bigger one is x, so it becomes s degrees minus 60 degrees, the smaller one. Okay, so if you cross over to be theta plus 60 degrees, which is equal to x. So x is equal to, theta is already known to be 25.06 plus 60, and that will be 85.06 degrees. Okay, so 06 degrees what? West. So the question says we should correct it to 3 significant figures. So this would be approximately 1, 2, 3, 85.1 degrees west, in bracket 3 significant figure. Okay, so that's the number 1. So that becomes the latitude of Q. Secondly, we should find that's the longitude of Q. Secondly, we should find the latitude of Y. The latitude of Y, which is this one here. Remember, the latitude of Y is along the parallel of longitude, along the meridian. So we have a Q and we have a Y. So we're supposed to find it. Already they gave us the value of the distance QY, which is 500 kilometers. Okay, so that means we need to use the formula for QY. So the formula for QY is going to be, right, this is the second question. QY is equal to theta over 360 times 2 pi capital R, because it is along the meridian. All right, so let's calculate the already the distance QR is given, which is 500, which is equal to theta, which we don't know, over 360 times 2 times 22 over 7 times 6400. Okay, so theta will be equal to, cross multiply, 500 times 360 times 7 all over 2 times 22 times 6400. Distance, the angular difference there is 4.47 degrees. Okay, 4.47 degrees. Now if we check this, our diagram, the distance along this x degree west, the 2 locations there are Q and Y. So for Q we have 50 degrees. Now we have to use it to find the lower one, which is Z degrees north. So this implies that theta is equal to the bigger one, which is 50, minus the smaller one, which is Z degree. Okay, so if you collect like terms, Z degree will be equal to 50 minus theta. So Z is going to be equal to 50 minus 4.47 and degrees north. Okay, so approximately to 3 significant figures is going to be 45.5 degrees north. You now write 3 significant figures. Okay, so that is the second question, the second part of the question. Very simple, very simple.